Welcome back to the deep dive. Okay, so you asked us to really get into the digital cinema package, the DCP. Specifically, how to create one properly in DaVinci Resolve Studio. We're aiming to give you the direct path, skip the usual headaches for theatrical delivery, and let's be clear up front. A DCP isn't just like a fancy MP4 file. It's fundamentally different. It's a whole distribution standard run by the DCI.
Yeah, exactly. And the core idea really is its structure. It's not one file. It's like a container, a specific folder layout. It's modular. You have separate files for video, for audio, for subtitles, all wrapped in something called MXF.
Material exchange format, right? MXF.
That's correct.
And that modular thing sounds really efficient, like if you have different language versions.
Absolutely. You can just swap out the audio MXF file, keep the same, huge video file. It saves a ton of space and time.
So how does the projector know what to play and when?
Well, that's all down to the metadata. There are these three critical little XML files that are like the blueprints. You've got the composition playlist, the CPL. That tells the system the playback order.
Okay, the sequence.
Then the packing list, the PKL, that's basically an inventory check, lists everything that should be in the package.
Like a manifest.
Exactly. And finally, the asset map. It just tells the server where to find each file within the folder structure.
Right, so CPL is the story order, PKL is the parse list, asset map is the actual map. And if you lose one of those XMLs, even though they're tiny.
The whole thing can fail to ingest or play. Yeah, they're crucial.
Okay, let's tackle the big technical hurdle everyone seems to hit. Compression. Why JPEG 2000? Why not something more common like H.264 or something?
Yeah, good question. It comes down to reliability and quality consistency in the theater. JPEG 2000 is what's called an interframe codec. It uses wavelets. Basically, every single frame is a complete picture encoded on its own.
Unlike H.264, which looks at changes between frames.
Precisely. With JPEG 2000, there's no dependency between frames. So playback is super stable, frame accurate, and the quality is consistent. The DCI caps the data rate at 250 megabits per second.
Which sounds pretty high. Does that mean massive render times are the main issue, or is it still color?
Render times can be long, sure, but where things often go wrong, really wrong, is color. That's what leads to that dreaded washed-out look people complain about.
The washed-out nightmare. Okay, what's happening technically when the color goes bad like that?
It's nearly always a color space mismatch. You see, the cinema standard, the DCI standard, mandates XYZ's color space.
XYZ, okay.
And usually paired with the DCI P3 color gamut, which is wider than, say, standard Rec 709 that you'd use for TV or web video. So if your source was graded in Rec 709 and the conversion to XYZ isn't handled correctly, boom. Washed out, low contrast, desaturated.
So what's the fix in Resolve? Do you have to, regrade it?
No, absolutely not. Trying to manually grade your way out of it is the wrong approach. The key, for you listening, is setting your project settings correctly before you render. Your timeline color space needs to match your actual grade. Usually that's something like Rec 709 Gamma 2.4.
So you tell Resolve what you started with.
Exactly. Then Resolve's color management uses precise math to do the conversion to XYZs correctly during the DCP render process. Get that setting right, and Resolve handles it. Skip it, and, well.
That's it. Got it. Okay, moving on. There's this big choice you have to make early. Interop or SMPTE?
Yeah, this is fundamental. These are the two main DCP standards. Interop is the older one, kind of the de facto standard from around 2004. Its main limitation is frame rate, only 24 or 48 frames per second. But the huge advantage, compatibility, it works pretty much everywhere. Old projectors, new projectors, it's the safe bet for a standard film.
And SMPTE, that's the newer, more official one.
Right, formalized around 2009. SMPTE is much more flexible. It supports higher frame rates, 25, 30, 50, 60 FPs. It also handles things like high dynamic range, HDR, and immersive audio like Atmos.
Sounds better. What's the catch?
The catch is compatibility, specifically backward compatibility. Some older gear, particularly DLP Series 1 projectors, might struggle with certain SMPTE features. Subtitles are a common issue on those older systems with SMPTE DCPs.
So SMPTE gives you more options, but Interop gives you peace of mind it'll play anywhere.
That's a good way to put it. Choose based on your film's needs and where you expect it to play.
Okay, nearly there. Let's quickly touch on audio configuration. It's not just about the sound quality, right?
No, the layout is critical. You need 24-bit PCM audio, sure, but the 5.1 surround sound channel order is absolutely fixed. It must be left, right, center, LFE.
LFE, the subwoofer channel.
Right. Then left surround, right surround. L, R, C, LFE, LS, Rs. That specific order. Every cinema server expects that. In Resolve, you use the Fairlight page to map your individual audio tracks correctly into a single 5.1 output bus that follows that order.
Don't just hope Resolve guesses it right.
Definitely not. You have to explicitly set it up.
Okay, final check's done. Let's say you've rendered your DCP, it looks okay on your machine, you're sending it off digitally. What's the absolute last piece of advice, the one thing you must do?
Well, first, proper QC quality control is non-negotiable. Software players can check the files, but honestly, the only way to be 100% sure is a test screening in an actual cinema.
Right, see it on the big screen.
But assuming you can't do that for every delivery, when you send it digitally, always zip it up, put the entire DCP folder into a single compressed archive file. A ZIP or maybe a tar file.
Why is that so important?
Because DCPs have lots of files, including those tiny, crucial XML metadata files we talked about. If you just drag the folder to a cloud service or FTP, sometimes those small files can get lost or corrupted during the transfer. Compressing it into one single archive file protects the integrity of the whole package. It prevents those small, vital pieces from getting lost. That simple step can save you from a failed delivery. It's your insurance policy.